Today we're going to look at the product and quotient rules with different representations. So far, everything we've done has been with an analytical representation, or in other words, an equation. But we need to look at all of the other ones as well. So first, just to review, let's look at the product and quotient rule. Remember, these are memorized formulas. So if you haven't memorized them yet, please do so within the next few days. We'll use them now and throughout the rest of the course. So just to get started, so that you understand the different representations, let's look at this example. It doesn't have anything to do with the product or quotient rule, but I think it'll help get things started. In this problem, we don't know anything about f or g, even though they're in the problem itself. All we know is that h of x is defined as f of x plus g of x plus 2x minus 7. What I want to do is write the derivative of h. But again, since we don't know what f and g are, it makes it difficult. Really though, all we're going to do is just write a notation for it. So in this one, I could represent the derivative of h as the derivative of f plus the derivative of g plus derivative of 2x minus the derivative of 7. The notation for the derivative of f is just simply that prime notation. So that'll be f prime of x. Same thing for g of x. I don't know what it is, so I'll just use that special notation with the prime of g prime of x. The derivative of 2x is 2, and the derivative of negative 7 is 0. So this is all we can do. It's the complete expression for the derivative of h. And we're done. So now let's go to an example. All right, suppose that h of x is f of x times g of x. Then there's a list of all the given information. We're supposed to find out what h prime of 2 equals. So here, instead of being given an actual equation, we're just given specific information in a numerical format. Okay, we'll start with the definition of h of x. This is equal to f times g. So I can't just write little primes on the answer and be done with it. It needs a product rule. So off to the side, let me put some important information. In this one, u is equal to f of x, and v is equal to g of x. Okay, then to show u prime and v prime, I'll use that prime notation for both f and g. Now for the product rule. H prime of x equals u prime v plus u v prime. In the last example that we did, we just left it go. We didn't know any more information about the functions. But here we do. We have list of information. Unfortunately, though, only at the point 2. Now, we're asked to find h prime of 2. So everywhere you see an x in this expression, I'm going to put a 2 in its place. This will be f prime of 2 times g of 2 plus f of 2 times g prime of 2. Every one of these expressions actually is up in the chart. And if it's not, we can't do the problem. We'd stop there. So the first one, f prime of 2, that'll equal negative 2. G of 2 is 5. F of 2 is 3, and g prime of 2 is 4. So the answer is going to be negative 10 plus 12, or 2. What's interesting to think about is, again, we didn't know what the functions f and g were equal to. All we knew is that h was defined as f times g. By using the product rule and the given information, we're able to find the specific derivative at 2 on the H graph. This is the numerical representation. And we also have graphical representations. So let's do both of these. F and G are functions, and the graphs are shown to the right. P of x is equal to F times G, and Q of x is equal to F divided by G. First one we're going to do is part A, P prime of 2. In this one, P is defined the same way it was in our last example. So I'm not going to do any new U's and V's. I'll just use the same ones from before. And from before, I knew that P prime, according to the product rule, should be U prime V plus U V prime. Remember, we're looking at this one specifically at the point 2. So everywhere you see an X, put a 2 in its place. This is a little bit different than the last problem. In the last representation, everything was given in a list format. This one's on a graph. So I'm going to have to think about what these notations actually represent. Let's start with the derivative, f prime of 2. If you remember, derivatives are just slopes of tangent lines. So what f prime of 2 is really asking you to do is to find the slope of the tangent line on the f curve at 2. That's right there. At that point, the slope looks like it's -1. So that's what the derivative equals. Next, we have to find g of 2. Now, this has nothing to do with calculus. This is just notation referring to the y-coordinate on the g curve at 2. Right up here, that looks like 1, 2, 3, 4. Again, nothing to do with calculus, just a y-coordinate. Here this is f of 2, so again, no calculus, just referring to the y-coordinate at 2 on the f graph. That's 1. And finally, g prime of 2. Now we're looking at derivatives because of the prime notation, so I need the slope of the tangent line at 2 on the g curve. This one, as we go up here, looks like up and over. So up 2 over 1 or 2. Okay, so putting this together, -4 plus 2 is -2. The same product rule is being used, just a different way to find the pieces of information that are needed. The next part of this asks to find q prime of 2. So in this one, we're going to need a quotient rule. Just to recall all the information that we needed from before, u was the numerator, u prime then would be f prime, v is g of x, and v prime is g prime of x. Same as before. To start things out, I'm going to write the quotient rule. U prime v minus u v prime. This is all over top of v squared. Now keep in mind, as it's written here, we really can't do anything else. But since the problem is asking for q prime of 2, I'm going to go ahead and fill a 2 in everywhere you see an x. So that'll be f prime of 2 times g of 2 minus f of 2 times g prime of 2 all over top of g of 2 squared. Okay, using the same things as before, I want to use the graph to figure out this information. F prime of 2, we saw this one before. This is the slope of the tangent line at 2 on the f graph. By counting rise over run, we determined before this was -1. g of 2 referred to the y-coordinate at 2 on the g graph. We said that was 4. F of 2 also refers to a y-coordinate, but this time on the f graph. That's 1. And the last part of the numerator, g prime of 2, now goes back to derivative, slope of the tangent line, at x equals 2. We counted that in the last screen as up 2 over 1, or 2. What's new here is, of course, the subtraction symbol in the numerator, and also the fact that we have a denominator. G of 2 we had found already to be 4, so I can just replace that in there. But then you're supposed to square it. All right, negative 4 minus 2 is negative 6. 4 squared is 16. So this reduces to negative 3/8. The derivative of q at 2 is negative 3/8. Your problem set that goes along with this section of the textbook is on the following pages. The entire problem set focuses in on these two representations, on the numerical and on the graphical. We've done plenty of analytical practice in class, and we'll continue to do so. But these two I'm going to have you do on your own. All right, good luck.